Good evening to you, student. Today I'm going to discuss this problem, though I have discussed with you in the class, but some of you said that they are not clear with this, they are not so clear. So again, I'm going to explain this, okay? So here forces, the question is here, forces P, Q, R act along the sides of a triangle formed by the lines x plus y equal to 1, y minus x equal to 1, and y is equal to 2. Find the magnitude and the line of action of the resultant. So here you are given forces formed by the three straight line. So one straight line is this one. So one straight line is this. You draw the xy plane. This is the xy plane. And if you plot in the graph, the line x plus y is equal to 1 is this, which is moving upward, okay, the direction, because taken in order along the side, formed by along the sides of a triangle. So we are taking the forces along in this direction. If this is in this direction, then here it should be in this direction, and this one is along the downward direction. And the forces y formed by the lines y minus x is equal to 1 is this line, which acts along the line, this one downward, okay. And the line y is equal to 2 is this is the line. So here this is the line x plus y is equal to 1, which acts upward the direction of the force P, and this one is the direction of the force R, and this one should be taken in order, okay. So this is the direction of the force Q formed by the lines y minus x is equal to 1. So as you can see here, so you can see here, this angle is 180, because this line, it made an inclination, or we can say that the slope of this line, this green one, okay, the slope of the line green one with respect to the x-axis, it is 45 degrees. So if you take, so if it is 45, so this angle here, it should be 180 minus 45. Similarly, the slope of the second line, y minus x is equal to 1, is again 45 here. So therefore here it will be 180 minus 45. And this one, it is along parallel to the x-axis. So the slope here is 180, we can say, because it is actually it is parallel, not lying along the x-axis, but it is parallel to x-axis. And the point of intersection of these two lines here, as you can see here, if you draw in the graph, it is the point 0, 1. So which means that the distance from here to here is equal to 1, and from here to here the distance is equal to 2. So this line here is 0, 2. The point D is 0, 2. So how to find the magnitude of these forces formed by the line of action? So first of all, we'll see that what is the angle of rotation, okay, with respect to the x-axis. So here, as you can see, this is the force P. This is the force P. So here, take the point O and draw a line parallel to, along the line, the x-axis. Take this point O, that is the origin. After that, you draw this force P, which is parallel to this one. As you can see here, this force P, okay, this one, it is parallel to this. And the second force is that since it is moving downward, okay, this force Q, okay, so draw a line here through this point O, force Q parallel to this one. So as you can see, this force yellow line here, they are parallel. So with this, we can see what are the angle of rotation of these lines. So as you can see here in this first figure, this one, okay, it is 180 minus 45 for this first line, since it is 45. So for this first line, the rotation is in this direction, so it is 180 minus 45. And for the second line, since it is moving downward, it will not rotate in the clockwise direction, but it will rotate in the anti-clockwise direction. So if it is rotating in the anti-clockwise, this force P, it will not rotate in this direction, but it will rotate in the anti-clockwise direction. That is, the angle from here to here is 180 minus 45, and from here to here it is 45. So 180 minus 45 plus 45 will give you 180. But from here to here, the inclination of this with respect, as you can see here, the inclination of this with respect to the x-axis, but since it is lying in the first in the second quadrant, so it is 40 plus 45. So 180 from here, and then another 45. So you have this theta 1, or theta 2 here is equal to 180 plus 45. Based on this, so let us see, as we know that this is the formula. Let X, capital X stands for the result part of the forces along the X axis. And the formula, as we know, it is X here. X is equal to x1 plus x2 plus x3 plus dash dash. Okay, x, and if there are n component of forces, and this x1 is p1 cos alpha 1 plus p2 cos alpha 2 plus dash dash from theory part pn cos alpha n. So here, as you can see here, p1 is equal to r, this force r, and what is there? Since it is parallel to the x-axis, that force r, as you can see, this is parallel to the x-axis, so the angle made by this is equal to 180 degree. As you can see here, it is parallel to the x-axis, positive direction of x-axis. So therefore, the angle made by this force r with respect to the x-axis is equal to 0 degree. Okay, so you have here cos of 0 degree, and then plus P2 here is this force P2 is equal to P only into cos alpha 2 here is the inclination of this line made by this force, with respect to the x-axis. So since it is moving in the anti-clockwise direction, so the inclination of this with respect to the x-axis, it is 180 minus 45. So alpha 2 here is 180 minus 45 plus cubed into cos of, that is x3. x3 here is called p3, and p3 here is cubed. Alpha 3 is 180 plus 45 degree. So 180 45 degree, because the inclination from here to here, it is 180, and from here, as you can see in the figure, from here to here it is 45. So therefore this one, it makes an angle, this force cubed, it makes an angle of 180 plus 45. So you have here plus of cube into 180 plus 45. But using what is cos A minus B, it gives you minus P cos, using the formula as here, cos of 180 minus 45 is equal to cos of 180 into cos of 45 plus sin 180 into sin 45, which is equal to minus 1, because cos of 180 is minus 1 into cos of 45. So cos of 180 minus 45 is nothing but cos of P into cos of 45 minus, again here, cos of 180 into plus 45 using the formula cos A plus B. Since cos of 180 plus 45 here is nothing but cos of 180 into cos of 45 degree, and then minus sine of 180 into sine of 45 degree. But again here, this is called to minus cos of 45 degree. So therefore you have here cos of 180 plus 45, you have minus cos of 45. That's why in the notes that I have given you, I'm writing it r minus p cos 45 minus q cos of 45. And how we get this? It is because of this, okay, where alpha 1 is called 0 degree, alpha 2 is called 180 minus 45, and alpha 3 is 180 plus 45. So from here, cos of 45 is 1 by root 2. So 1 by root 2. So you have r minus p into 1 by root 2 minus cubed into 1 by root 2 is equal to r minus 1 by root 2 into p plus cube. Similarly, with the y, the result part of all the forces, that is capital Y, we denote, and the formula for this is, for capital Y, okay, it is equal to y1 plus y2 plus the component forces along the y-axis, and this is equal to p1 sine alpha 1 plus p2 sine, instead of cos you have sine, okay, so and alpha 2 plus dash dash. So here the angle here alpha 1, as we know it, it is 0 degree, alpha 2 it is 180 minus 45, alpha 3 is 180 plus 45. So instead of cos, you just replace it by sine. You have r into sine of 0 degree plus p into sine of 180 minus 45 plus cubed into this, which is equal to p into, but sine 0, as we know it, is equal to 0. So here you have p sine 45 minus cubed into sine of 45. Why? Because sine of 180 minus 45 gives you this one, the formula that is sine A minus B is equal to sine of A into cos B minus sine B cos A. But cos As you know that sine of 180 gives you 0, so we have here sine minus sine 45 into cos of 180, but cos of 180 is equal to minus 1, so that minus sign you multiply with this, it gives you positive sign, that is sine of 45 degree, which is 1 by root 2. So when you substitute here the value of sine 45, what you get is 1 by root 2 into p minus q, name it as equation 2. And we know the formula for R, the resultant force here. The question, we have to find the magnitude of the force. This R prime here, so that you will not get confused, because in the question they have given P, Q, R are the forces. So usually we used to denote R as the resultant, uh, but here I have changed it to R prime, that is resultant force, so that you will not get confused with the force R given in the question. Okay, so R prime here stands for the resultant force, and which is given by square root of x squared plus y squared, which is called, so where whatever x you get in equation 1, replace it by this value, and if whatever y you get in equation 2, you replace it in this square root. So after simplifying, you will get the resultant R prime here, resultant R prime is equal to square root of r squared minus root 2 into r into p plus q plus p squared plus q squared. So this is the magnitude of the force. Next, you have to find, according to the question, you have to find the line of action of the resultant, and that also there is a formula. So for that, first of all, we have to find the moment of the forces about the point O. What are the moment of the forces about point O? So as you can see here, these three forces, they are not parallel, they are not passing through this point O. As you can see, this force R, it is not passing through this point O, but it is parallel. And what is the distance from here to here for this force R? It is 2 units. Okay, and what about this force PQ also? They are not passing through this point O. So therefore, this force P here, as you can see here, it is of inclination 45 degree. Now from here, what is the perpendicular distance of this force P from this point O? It is OM. So from here, so you have, this is force P, okay, in this direction, and this is point O. This is point O, and this force P here, this force P, that is the line x plus y is equal to 1, is, it makes an angle of 45 degree, or the slope of this line is equal to 45 degree. So here, what is the perpendicular distance from here to here? We denote it by OM. So what is OM here? It is equal to, you consider this right angle triangle. So if this is the angle here, so therefore this will be the perpendicular, and this will be the hypotenuse, and this will be the adjacent. So in that case, OM here, if you denote this as point A, so OM here, OM by OA gives you sine of 45 degree. And what is sine 45? It is 1 by 2. And what is OA? The distance from here to here, I think it is 1. If you plot in the graph paper, so it is 1. So therefore you have OM is equal to OA sine 45 degree. That is the perpendicular distance of this line P, of this line x plus y is equal to 1 from this point O. Similarly, the perpendicular distance of the second line Q, second line y minus x is equal to 1 from the point O. It is given to be OL, and OL also the same method you apply, you will get the value of, what is G? G here is the moment of the forces about O. It is equal to minus Ry, because this R here, as in this case, it is moving in the clockwise direction. So by taking the moment of the forces, if the force is in the clockwise direction, so you'll have you have to put negative sign. So let me just draw it briefly. I mean that. This is x plus y is equal to 1, and this is the line x minus y, sorry, y minus x equal to 1, and this is the line y is equal to 2. Force R is in this direction, force P is in this direction, sorry, this is P, and this is Q, which makes an angle of 45 degree, and here also it is 45 degree. So O is the origin, OL, OL, OM is here, and OL is this, the perpendicular distance of these two lines from the point O. So by moment of the force above O, it is the product of either of this product of the force into its perpendicular distance from that point O. So here, as you can see here, minus R into OD. Minus R, here we have point R, D, and since this force R is moving in the clockwise direction, okay, it is moving in the clockwise direction, so you have to put negative sign here, that is minus R into its perpendicular distance. What is the perpendicular distance of this force R from O? It is OD, and it is equal to 2 units plus this cubed. What is this force cubed? Force cubed into its, since this force, it is moving in the anti-clockwise direction, so therefore this force cubed, it is moving in the anti-clockwise direction, so we have plus sign here, okay, cubed into its perpendicular distance from the point O, that is OL, and then plus P into, what is the perpendicular distance of this force P? Again, this P also, it is moving in the anti-clockwise direction, so therefore it is positive here. You have plus P into OM, that is perpendicular distance. So when you draw, and we know that the distance from here to here, this point here, the point which it got the x-axis, it is 0.10, and here it is minus 10. So the distance from here to here is 1, and similarly from here to here, this is point A, it is again equal to 1. So as you can see here, OM by OO prime is equal to OO prime, okay, OO prime is this point of intersection of all of these two lines, okay. So you have minus R into 2 plus cubed into sine of 45. M here is this, if you draw here, as you can see here. So consider this as this one as the adjacent side, and this part as the perpendicular, that is OM as perpendicular, and this as the hypotenuse. So what we get is, or you can see from here also, you can see from here to here also, you consider this triangle, because if this is 45, then this angle, here it is M, and this is O, and this is O prime in the figure. So if this is 45 degrees, so this angle also will be 45 degrees, such that here you have 90 degrees since it is perpendicular. So if here you have 45, so means this angle also will be 45 degree. So OM here will be equal to OO prime. Okay, OM here is the perpendicular, so OM by OO prime gives you sine 45 degree, which implies that OM here is equal to OO prime into sine of 45 degree. But OO prime, the distance from here to here, as let me go back to this problem, the distance from here to here is equal to 1. So therefore, this implies that OL here is equal to OM. Okay, sorry, this is for P. OM is equal to OO prime into sine 45, that is 1 into sine 45. Similarly, with the second one also from this side, if you consider this is 45 degree, because here you have 45, so here also it should be 45. So this angle also will be 45 degrees. And now consider this right angle triangle OL O prime. So in that case, what is OL? OL is equal to OL by OO prime will give you again sine of 45 degree. But OO prime, as we know, it is equal to 1. So you just replace it by 1. So you have minus R into minus twice R plus cube into sine of 45 is 1 by root 2 plus P into 1 by root 2. So once you get the value of G, which is equal to P plus cube minus 2 root 2 into R divided by root 2, we can find out the value of the equation of the line of action. And the equation of the line of action is given by x into capital Y minus y into capital X minus G is equal to 0, where this capital X stands for the result part of the forces along the y-axis, and capital X is the result part of forces along the x-axis. axis. And we have got the value. What is that value? From equation 1 and 2, you just replace x and y by this equation 1 and 2 here. So we have the equation of the line of action is in, we have capital Y is equal to P minus Q by root 2, and capital X is equal to root 2R minus P minus Q divided by root 2. And what is G? When you bring it to the left hand side, it is equal to P plus Q minus 2 root 2 divided into R divided by root 2. As you can see here, root 2 is common throughout. So this implies that P minus Q into X plus, you bring this minus inside this, so this will become plus. So you have P plus Q minus root 2 into R into Y is equal to P plus Q minus 2 root 2 into R, which gives you the required equation of the line of action. I hope it is clear to you now how we get this alpha 1, alpha 2. As you can see, I have shown you in this figure, this line P, this force P, it makes an angle of 180 because it is rotating in the anti-clockwise direction. So 180 minus 45. For the second line Q, it makes an angle of 180 plus 45 because from here to here it is 180, and from here to here another 45 degrees. So it will move in the clockwise, anti-clockwise direction, as you can see here. So therefore you have the equation of the line of action is equal to this value as I've shown here. Okay.